What if I told you that India is about to become the fourth nation in the world to send humans into space? Yes, after the United States, Russia, and China, India is making history with its ambitious Gaganyaan mission. But what makes this mission so special? What are the biggest challenges ISRO faces? And how close are we to seeing the first Indian astronauts in space? Let's break it all down. The Gaganyaan mission is India's first crewed spaceflight program, designed to send 3 astronauts into low Earth orbit for up to 7 days. Led by ISRO, Indian Space Research Organization, this mission is more than just a milestone. It's a demonstration that India has the capability to independently develop human spaceflight technology, something only a handful of nations have achieved. This mission was first announced in 2018, and ISRO aimed to launch by 2022 to celebrate India's 75th independence anniversary. However, due to multiple factors, including the COVID-19 pandemic and technical delays, the timeline was pushed back. But despite the setbacks, ISRO has been rapidly advancing, testing essential technologies, working on astronaut training, and preparing for multiple test flights before the final crewed mission. So why is this mission such a big deal? Well, sending humans into space is one of the biggest technological challenges any space agency can take on. Unlike satellite launches, this requires advanced life support systems, astronaut safety mechanisms, and precise re-entry technology. If ISRO succeeds, it will place India among an elite group of spacefaring nations and open doors for future deep space missions to the Moon, Mars, and beyond. It will also boost India's standing in global space exploration and attract international collaborations for future crewed missions. But how exactly will ISRO achieve this? What are the biggest hurdles, and when can we expect the first Indian astronauts to take off? The Gaganyaan mission will use India's most powerful rocket, the GSLV-MK3, which has now been renamed LVM-3, Launch Vehicle Mark III. This rocket has been tested extensively and has a proven track record of successfully launching heavy payloads into space. The LVM-3 is a 3-stage rocket. First stage, 2 solid rocket boosters providing the initial thrust. Second stage, a liquid-fueled core stage. Third stage, a cryogenic engine, powered by liquid hydrogen and liquid oxygen, capable of precise orbital insertion. The crew module will be a specially designed spacecraft that can support 3 astronauts for 3 to 7 days in low Earth orbit, LEO, at 400 km altitude. It will include advanced life support systems, providing oxygen, removing carbon dioxide, and maintaining a stable cabin temperature. Radiation shielding, protecting astronauts from harmful cosmic radiation.
Emergency escape mechanism, allowing astronauts to abort the mission if something goes wrong during launch. The Crew Escape System. To ensure astronaut safety, ISRO has developed a crew escape system, which can eject astronauts to safety in case of a launch failure. This system has already undergone multiple successful tests and will be further refined in upcoming trials. Astronaut selection and training. ISRO has selected 4 Indian Air Force pilots for the mission, who have been undergoing rigorous training in both India and Russia. Their training includes zero-gravity adaptation, learning to work in a microgravity environment. Spacecraft operations, handling the spacecraft's control systems and responding to in-orbit emergencies. Survival training, in case of an unexpected landing in remote areas. However, human spaceflight comes with significant risks. Here are some of the biggest challenges. Surviving re-entry. As the crew module returns to Earth, it will experience temperatures over 2000 degrees Celsius due to atmospheric friction. The heat shield must be able to withstand extreme conditions to protect the astronauts inside. Zero-gravity effects. Long exposure to weightlessness can cause muscle loss, bone density reduction, and fluid shifts in the body. Astronauts must be prepared for these changes. Radiation exposure. Outside Earth's protective magnetosphere, astronauts are exposed to higher levels of cosmic radiation, which could pose health risks. Perfecting the landing. Unlike regular satellites, the Gaganyaan crew module must return safely, using parachutes for a controlled splashdown in the Indian Ocean. If Gaganyaan 3 is successful, India's human spaceflight program will expand rapidly. Here's what the future could look like. Gaganyaan 4 and beyond. Future crewed missions could extend the duration of human spaceflight, potentially leading to longer stays in orbit. Bharatiya Space Station. By 2035, ISRO has ambitious plans to develop an independent Indian space station, where astronauts can conduct scientific research in microgravity. Lunar mission, with NASA and Russia. After Gaganyaan, India could collaborate with NASA, Roscosmos, or ESA for crewed moon missions, possibly participating in the Artemis program or a future lunar base. Mission to Mars. India has already sent an orbiter to Mars, Mangalyaan 1. A crewed Mars mission might be possible in the 2040s, aligning with NASA's and SpaceX's plans. If all goes well, India's first astronauts could launch by 2025. This would be a historic moment for Indian space exploration and a giant leap forward for ISRO. What do you think about India's Gaganyaan mission? Will it succeed on its first attempt? And what should be ISRO's next goal, a lunar mission, a space station, or a Mars mission? Let's discuss in the comments. And if you love space and technology, subscribe to New Facts for more mind-blowing updates on the universe.